So if you've never used a Microsquirt, you might wonder how they hook up. They actually use a 2.5mm jack, like a microphone jack. They're usually 3mm on headphones or anything, but this one uses a 2.5mm jack, and you basically just plug into it. It actually works out to just being 3 wires. Those 3 wires then run to a DB9 serial connector. Then we use from DIY Auto Tune this FTDI driver that converts it to USB so that it can be used in any of our laptops. So you basically hook that up and plug it into your laptop and go. And that's really all it takes, as long as you got the driver installed. It works on Mac or Windows. So if you're like me who has Windows running on a Mac, then you got everything taken care of. But we basically just get into Tuner Studio here and set up a new project and get this car at least showing the laptop if it thinks it exists and if it thinks there's RPM. So I'm gonna get the battery hooked back up and plug this back in. I've also unplugged the ignition coil. We're converting to a smart coil. Microsquirt can't handle actually the amp load that those coils handle when they discharge. So just to be safe, I've unplugged it so that it is not even a factor that we're gonna deal with of possibly overloading the Microsquirt. So battery's hooked up, not a big spark. So we're now gonna flip the key on, watch for smoke, listen for noises, hope for the best. Fuel pump prime for 2 seconds. That's on the aftermarket ECU. So that actually worked perfectly. So far so good there. No weird noises, no smoke. Okay, let's see if the laptop will see the Microsquirt. No reason to believe it won't since that fuel pump triggered. But let's go through this process real quick. We're going to create a new project. And we're going to call it Cappuccino. And then in this, you try to have it find the Microsquirt itself rather than just trying to force in some numbers and see if it works. It has a nice feature to actually try to find it for you. So if all goes well, it'll show up here very shortly because it's usually one of the last options when you're using the FTDI adapter. No, not what we wanted. Okay, let's just cancel. Okay, gonna jump away for a little bit and we'll come right back with this hopefully working. Okay, we're finally back to making progress. So we have gone in to detect the device and it has found it here. So we're gonna accept that, name the file, progress, making progress. Okay, we don't need to set any of these things, especially not at the beginning. It's not important. It just tested the port for us and it said it's successful, so we're going to jump to the next screen as well. This is just a default. You can pick any of the dashes that you like. Is this one I've created? I don't think so. So we're just going to go back to default. It's a good place to start. Now that we're hooked up, so the first thing we're going to look at in our situation is the fact that we have new sensors that aren't a part of this. So throttle position, obviously way off. We don't need it to be that way. So you can come up here and you can calibrate. Now, since I know I said we don't have a throttle position sensor, but in this one, we just want it to calibrate down to where it thinks is at 0. So we're just setting current to 0. We're going to accept it. It's just going to drop it right to 0. So that's just going to make it where there's not some weird table somewhere that's adding fuel because you're out of throttle position or something. So we're good there. Next thing we want to deal with is temp sensors and map sensor to try to calibrate them. So let's see what they've got for us. We go in here to unlock calibrations, burn that in. Thermistor tables this is where like standard GM stuff comes into play. So we're going to select comment and we're going to see if they've got nothing Suzuki. So we kind of decided that it is a Denso ECU. So let's see if that works out. It's about 62, 63 degrees in the shop here. And that did not get us where we want to be. So we can get in here and we can fiddle. This car has 2 coolant temp sensors, one of them for the gauge and one of them for the ECU. So we're going to be able to compare them, and it's going to be really helpful to do that. So let's go real quick and just give us manifold air temp. We can see that they're pretty close to each other. So the sensors with the same calibration are reading about the same temp in here. So the next thing is going to be map. And this is also up in here. You can calibrate your map sensor. Obviously, they're not going to have Suzuki in here. So if we go in, and this car, I'm going to hope for the best that it's like a 2-bar map sensor. Let's see how that puts us. It got us a little closer. We need to calibrate right here the 0 and 5 volt signal, because right now we should be at 101 kPa. So if we change this to 220, I thought raising that. Nope, going the wrong way. So let's try 190. Okay. This is looking like it's a 1.5 bar map sensor. If the scaling is anyway correct, there's a good chance the 0 volt scaling is just completely off. And so we're just putting arbitrary numbers in here just to get the gauges looking right for a starting point. So the next thing we go through is basic settings. We're going to come in here. Engine displacement. Oh, wow. At 2,000 cc's, it's crazy to think that that's way too big, but it's way too big. So 3 cylinders. I think we figured out the injectors are 180 cc injectors. And so this... Okay, so it's telling us that we need to change from alternating to simultaneous, which is totally fine. And we got to do 1 squirt per cycle. So it needs to be simultaneous because it can't alternate the injectors when one circuit has 2 injectors and the other circuit has 1 injector. So we want it to be simultaneously firing every single injector, and we only need it to do 1 squirt per cycle. That's weird that it doesn't let you do any more than 1, but it doesn't make a difference. Okay, we need to let it know that it has 3 injectors, even fire motor. All of this is perfect. Wants us to cycle the key when you're sitting in the passenger seat. A little bit of a process here. Luckily, it's a tiny car. Okay. Next step, general settings. No barometric correction. We're not working with, this is lag factor on any of our sensors. We're not dealing with that at all. For primary fueling, we want speed density. For ignition, we also want speed density. We are not having a secondary fuel table because we have no throttle position sensor. So everything needs to be set to speed density. All that looks great. Tachometer output, we're going to leave this off for now. I'm using a wire that runs to... Oh, lovely. It didn't like whatever we set our throttle position sensor to. So that one might be one we just completely ignore for a while. Might even just turn it off on here. Another trick that I do is manifold air temperature, air density table. I've had a lot of cars that when they heat soak, the sensor will basically stall out at startup. Most of our tuning, most of our fueling does not matter. So if you get down to 100% and just flatline it, it adds a little bit of fuel when it's cold, but it doesn't pull fuel when it's hot. You never want a situation where you have a heat soaked intake, and so because of that, all of a sudden fuel gets pulled. It is not an ideal situation to not know why it's happening. We will deal with all these things later. This is our air to fuel ratio table. This is our VE table. We'll need to go and calibrate one of those. We're not dealing with that at this moment. The main thing we're dealing with right now is seeing if we can get a tach signal to show up on the laptop. So we're going into the ignition wheel setup. We are a toothed wheel. Actually, it's probably considered basic trigger. And this angle offset that it offers is what we're going to be putting in whenever we figure out how far off our timing is. So if we command 10 degrees in here and it's showing on the crank at 8 degrees, we can put in a 2-degree offset, and that way what it does is what it thinks it does. And so that's the kind of crucial component on making sure when you're asking for 40 degrees of timing, you get 40 degrees of timing. Honestly, all this is going to be just fine. I need to get in on DIY's site to figure out the dwell settings for this coil and the cranking dwell for this coil. All that will come into play. We are going to start with fixed timing. We're going to just do a 10-degree fixed advance. That way we have something easy to guide for while we're cranking the motor. So we're burning all that in. Now their power cycle. Okay, yeah, throttle position is not going to be a thing we deal with, because if every time it cycles, it's just some arbitrary number. Yeah, we're just going to set it back to 0 and let it be whatever position it thinks it is. And we're going to make sure that nothing is based, which actually is under acceleration enrichment here. We have it turned off to use throttle position. We don't want that. And this is set to 100% throttle position base. We want it set to 100% map sensor base. So we'll deal with this table later. But we just want to see now, are we getting an RPM signal? So I'm going to flip things around here and go over to the driver's side and do some cranking and see what we get. Moment of truth. Out of gear. Nothing. Okay, that was the fear. Can't say I didn't expect it to not go as planned. We're going to attempt to do falling edge. We're going to see if that makes it happier. Nothing. I'm going to switch my inputs on the ECU from opto to VR sensor, and I'll get back right with you guys. Let's get back to it. Probably gonna have laptop engagement issues, or it doesn't want to detect again, you know, just right when you're attempting to deal with all the other stuff. Oh, I switched which side it's plugged in on, and magically it started working. Okay, we still don't know if changing that's going to affect anything, so let's see if we get a signal when we crank. Other than a crazy spike at the beginning, we have RPM. We've got success. We don't know if this will be a problem when it comes to one of the problems with VR sensor inputs is they will get too high a voltage at higher RPMs, and since we're dealing with a 9,000 RPM engine, we really have to be careful about that. So we might have to add a resistor between those pins to kind of curb down how high the voltage will get. But as of right now, we've got RPM, we got sensors showing. We'll work on testing the map sensor, getting some range out of it, because we need to get it fairly calibrated since we are dealing with no throttle position to tune off of. It's all going to come down to what the map sensor says. And then again, with tuning like this stuff, what you're going to learn is it's all relative. If we say our VE is 50% and our injectors are 30% bigger than they really are in the tune, your numbers are skewed. So tunes are relative. One car to another car is not going to be the exact same thing, and you can cheat things through. So like if ours, we know we have 0 PSI set well, and we know right when atmospheric pressure starts to become positive pressure, we at least know that at that transition point you're getting into boost. So even if the map doesn't read exact vacuum or exact boost, we at least know that we have a starting point that we can base fueling off of. Then we can go in and calibrate. And honestly, we can go in and swap to a GM map sensor, any of that stuff. Now that we have these things started, we're at least at a better place to go forward. So I'm not really sure what the next step is because I'm not thinking things through yet, but this is huge. So I'm going to start in on probably cutting up the wiring in the engine bay, and then getting this wideband sensor mocked up and installed. So let's get right to it. So now that we've got the ECU, seeing RPMs and everything, we're going to start eliminating the components that the factory had for emissions control. It looks like they have a solenoid that actually would stop the blow-off valve from opening. So I'm guessing on like low boost levels, you don't get the whoosh. You actually keep your power growing between gear shifts if it was low enough boost. We're going to actually eliminate all that. We're going to make this a lot more mechanical system. The problem with having a Suzuki Cappuccino in the United States is finding parts isn't necessarily an easy thing to do. So by eliminating these components, we're going to hopefully make the car a little bit more reliable and make it where if something does fail, it's available and we can get it. The special injectors that these have factory that might be hard to work with a stock computer, we don't have to deal with that being a situation anymore. We're going to be swapping in bigger injectors. We're going to be eliminating solenoids that control things that aren't needed to be controlled. We're going to get the EGR blocked off so it's not sooting up the intake. I'm not sure if I'm going to be able to use the wideband into the factory O2 sensor hole, but we're going to see. It might be one of those angles that you just really don't get to it. So I'm either going to pull the downpipe and make a whole new downpipe to get this car having a full 2-inch exhaust system, or make a attachment that goes on the bottom of the catalytic converter and put the O2 sensor there. So I'm going to just kind of play it by ear and see what we can make work. But either way, let's start tearing stuff apart. So what we've got right here is the original ignition coil and the wiring running to it. It's got 2 wires. Our new ignition coil has 5 wires. This being a old school high amp, fairly noisy ignition coil, it actually has tucked right in here a noise filter. We are not using this anymore since we're using a smart system. We're actually using a TAC output that should be a nice clean signal to give the input to the tachometer itself and to the AC controller. I'm going to remove that noise filter and get this all set back up to run the way I have it designed on the wiring diagram and go from there. So what we've done here is we've actually pulled back. There appears to be a exhaust gas temp probe. Not really sure if it's just a overheat protection on it. But then we've also got the ignition coil wiring here, this black and white and brown and white wire. And then the other 4 wires here are the O2 sensor. And we're going to be relocating the O2 sensor and eliminating this entirely. So we're actually going to use this O2 wiring to get us our, hopefully, sensor ground and our, what's the other wire? Oh, our sensor ground and our TAC signal out from the Microsquirt into the harness, since there really isn't a way to get to it up here because it went through that noise filter beforehand. So this is the ignition coil we're going to be using. It is a amp EFI. I've purchased it through DIY Auto Tune. It is a smart coil, but it's actually rated to spark at the RPMs that this motor is going to go to, and it's going to have to spark every single cylinder. Because with a distributor, this coil fires 3 times for every 2 revolutions on a 3-cylinder. So it's got to be able to fire at 9,000 RPMs 4,500 times per minute. So it really has to, actually 4,500 times per cylinder per minute. So 13,500 times per minute. So it's got to do a good job. So I'm going to be able to basically adapt this, give a little bit of harness length, use the included connector with crimp-on pins and wire this all in and actually have it be just direct good to go. So that is going to be the next step. These pins are a very similar crimp style to like a weather pack or pretty much anything out there, where they consist of kind of a staged crimp on the wire itself and a staged crimp on the insulation. So I use this little 5-stage crimper to do all of my crimps this way, and it works really well, and these crimpers are cheap for what you're getting. So this style connector, you actually have to feed the wire in first, then crimp the pin together, then put it through. So we're going to go down the list from A to E one at a time. That way we don't mess it up and get it right. So we're going to start with the ignition wire, which is this brown and white wire. And I'm going to cut it to the length that the shortest wire I have is going to end up being. That way I don't end up with too goofy of a setup. I'm actually going to feed it through right now because it's always harder to get when there's stray wires hanging out. It's a lot harder to do. So we're stripping it there. Crimp this guy on. I think I totally did that wrong. If this is really the pullback style, I hate that style. Yep, that's definitely the crimp on and pull back through style. So ignore what I just did. Luckily it came with one extra pin. I'm sure they know people will mess it up the first try. So let's do it right this time. Feed it through. Now you pull it back through. And it's in there. I really don't like this design. But let's carry on through. So we're just finishing up the power and power ground wires here, and then the last wire they want you to run is a ground directly to the head so that you have a good solid path for the spark to travel and any noise is interrupted through that path. So we're actually going to leave that fifth one open, and then I'm going to just, once I get this mounted where I want it, we're going to end up running the fifth wire right along down to this head, little stud on the head here. Actually, there's a couple cover bolts, but we'll probably use this back of the cam cover and just tie in right there. The other thing we have to do here is accomplish getting the wiring that was set up for the noise filter removed and bypassing it with our now filtered output and hope that that goes well. We're gonna go build a spark plug wire that hooks up to this. Off camera, I went ahead and removed a couple solenoids. The battery died. I can't really give fair excuses, but basically we removed a number of vacuum solenoids. It's just some of the stuff they did back in the day to control stuff with a simple 12-volt switch using vacuum or boost. So in this application, we've ended up with 3 or 4 different fittings that need capped off, and I've ended up stockpiling some really nice silicone caps. So we're going to get those installed real quick and get this where the intake is vacuum tight again. I'm going to eventually see if these are just pressed in fittings. That way we can actually just knock them out and have nice little aluminum plugs that go back in the holes. But for now, we're going to do it this way because it's quicker for the testing purposes, and really just want to know if this is working or not. Basically got it all wired up now, so what's left to do is try to start it. These are one of those situations where you can go through and you can test as many things as possible and hope you end up finding exact information on ignition advance, on the timing mark, on all that stuff. Or you can just try. If it fires up, you know you're at a good starting point and you can start adjusting from there. So what we're going to do is we've got it all sorted. We're going to look for a tach signal. We're going to look for try to hear it fire off. We're basically just gonna go through those steps and see what we can come up with. So here we go. Sometimes you get lucky with a gigantic vacuum leak that I can hear, but still, it's running. This is awesome. Unfortunately, no tach signal. Let's figure out that vacuum leak I missed. Oh, yeah. Needed one more cap right down there. It's nice to know that that's full vacuum at that spot, but it's also not exactly what we wanted. So that's awesome. That's great news. The new coil's working like it should. Everything's actually going good. Of course, this next time it fires up, it's going to struggle because there's this leak that was there was really helping it idle, but it was idling fairly high. So hard to say if that was really the 3,000 RPMs it says it was, but let's go ahead and get the garage door open and get it started back up and see if we can test some things. I forgot to turn the tach output on. Here we go. Much lower idle. This is what I was expecting. with 3 cylinders, not like idling that low. Okay. I still was not getting tach signal, which is kind of sad, but might be part of the process. Maybe it needs that noise filter still. I'll have to dig in and see what it thinks on that. But for now, we got a running car. I'm gonna crank up the idle, try to lock it in a little higher, and try to get my timing set, because we should be locked in at 10 degrees, and I'm gonna test it and then get back with you guys.